We have a question here. The question is on simply, you can see here, ampere circuit based, a coil wrapped around a toroid. I'll write the question also now. A coil wrapped around a toroid has has inner radius 2 centimeters, 2 centimeters, and outer radius 25 centimeters. Outer radius 25 centimeters. If the wire wrapping makes 800 turns, if the wire makes wrapping 800 turns, 800 turns and carries a current of 12 amperes. 12 amperes. What are the maximum and minimum values of magnetic fields within the toroid? What are the maximum and minimum magnetic fields within the toroid? Within the toroid. Okay, first this question belonging to which topic? First we need to identify this is belonging to the toroid and toroid based numerical. First write the given data. A coil wrapped around the toroid has inner radius. Let us say inner radius is 2 centimeters. Outer radius having 25 centimeters. Let us say little larger distance. Okay, 25 centimeters. Sorry, it is not 2, 20, 20 centimeters. Why this one difference? That's what. Yeah, 20 centimeters. Means R1 20 centimeters, R2 25 centimeters. So then if R1 and R2 radius has given 800, number of turns is given 800, and the amount of current which is flowing through that is 12 amperes. The question is that what are the B maximum and B minimum? B maximum and B minimum, before that you are going, you should know that what is a magnetic field at the toroid, at different places in the toroid. Do you have idea?
Um, yes, um,
What's the formula for that?
um, it's not coming now. Yeah, B is equal to nu naught n pi.
So I told you n equal to number of turns per unit area means 2 pi since circumference. Area means R1, R2 like that it will be. But it is R1, R1, R2, R2. So for example, inner radius if you are taking inner, I can write mu naught and n in place. This is n into a means capital N equal to n into a we will write usually. This is the way we will write. Okay, since we are writing this, then n by a we have to take. So capital N by a into I. Okay, into I. What is this into I? I is a current. Current which is flowing through the toroid wire. So now mu naught value 4 pi into 10 to the power minus 7. N for number of turns 800 by area 2 pi a, inner radius 20 centimeter. Convert into meter, 20 into 10 to the power of minus 2. Next, I is 12 amperes. If you calculate this, simply 2 pi, I get cancelled, this is 2. Now I have 10 to the power minus 7, here 2 is there, and down 20 is there. What I'll do, 2 1 ja, here 20 is there, no? 10. 10 to the power minus 2, this is here minus 4. Then minus 5, minus 2 cancel. One more 10 is also there. So this is, I cannot cancel with that. Then I'll, this one I'll cancel. And if I cancel this 0, then minus 4. So I have easily 12 into 10 to the power minus 4. So this I can write 1 0 if I'll write down 1.2 milliamperes I can write. Can I? Simply what I did, this 1 0 I have taken for the division, therefore this one has come. If I could multiply and divide, then it will be 12. So this is a inner magnetic field, no? So milli Tesla we can write that. Next, after this, anything left in that? Everything has covered. 8 left. Forgot. 8 into 12. How much? 12 is 96. Right?
Yes, sir.
So 96 in the sense 9.6 millidecimal. So this is the inner. Okay. Now we can also find the outer one. What is the outer one? The same formula, but we have to use the radius value is different. Since number of turns are same, then the outer surface, at the outer surface, whatever we are having, at the outer surface what we are having, b equal to mu naught ni. This is again we can write a mu naught capital N by a, 2 pi radius r2 into I. So mu naught 4 pi into 10 to the power minus 7 into n for what? Number of turns 800 and 2 pi into R2, 25 into 10 to the power minus 2 into 12. 2 pi and 2 is left 10 to the power minus 2 and 10 to the power minus 7 minus 5 and these two also considered minus 3. Okay. Now here you are having 2 into 8 into 12 into 10 to the power minus 3 by 25. This can be written as further b equal to. How can I write? 12 is 96. 96 2 ja 96 2 ja
200 and 202. No, 192, sir.
192. 192 by you have 25 into 10 to the power minus 3. So 192 by 25, how can you divide? Is in the picture. With the 25, how it will go? This is we will consider as a milli Tesla. So 192, if you consider with respect to 25, 7 jar. 25 8 jar actually 200. 25 7
Yes,
jar
it has
170.
173.
So
Sorry,
it is
175. Right.
175 in the sense we'll left you are having around 23 left here, I think. 23, right? Or
No, sir.
18.
It'll be yeah, it'll be 17, like 17.
17, yeah. 17. So let us say 25 will not be decimal, 0. Then what I'll take again 170 in the sense
7.06.
5, 6, yeah, 150. Then again I have 20. So 7.6 something I'll get.
So
7.
7.06, right?
Not 0, 6, 7.6. Since I kept the decimal, I got a 0 here.
Yeah, yes, sir, 7.6.
7.6 milli Tesla I'll get. Okay. So 7.6 milli Tesla. If you do further, little more will come. With the since 25 means again after 7.6, if you check another number. Okay, 7.6 milli Tesla is maximum magnetic field. 1.6 milli Tesla is maximum magnetic field. And whereas minimum magnetic field, how much? We got it's B inner 9.6 milli Tesla, which is 7.6 milli Tesla is larger than the previous one. Okay, this is in the case of Ampere circular law is one question. There is one more question also, very simple one. A solenoid of length small. A solenoid of length, a solenoid of length, zero point 0.5 meters. Length how much?
zero point 0.5 meters.
0.5 meters. Has a radius 1 centimeters and is made up of 500 tons. 500 tons. 500 tons. It carries a current of it carries a current of 5 amperes. 5 amperes. What is the magnitude of magnetic field inside the solenoid? What is the magnitude of the magnetic field inside the solenoid? Till now we have discussed about the toroid. Now here it is solenoid. Solenoid means we are having solenoid like this, right? Whatever the number of
Yes,
turns are there, we have measured depends on the unit length. More the length, more the number of turns we can expect. So in previous case toroid we took n by a, right? Now here n equal to n by l here. Okay. So
yes.
first n by l you are going. What is the formula? B equal to mu naught
Mu
ni r.
naught.
So let us see that how much it is. B equal to mu 4 pi into 10 to the power of minus 7. This is constant. Same like in Coulomb's law, 1 by 4 pi epsilon naught q is equal to 9 into 10 to the power of 9. Right? There it is. Same here, 4 pi into 10 to the power of minus 7 is constant. Mu naught equal. Now let us say if you substitute here, how much it is? 4 pi into 10 to the power of minus 7 into n number of times 500. Length is zero point 0.5 meters, right?
Yes, yes.
into what else we are having? I for
current, 5.
five objects. Then they also mentioned here radius. Why did they mention the radius? Any idea?
Um,
Obviously, length is supposed to be greater, large greater. Okay, let us say we will
yes.
get in on this.
For the other formula,
Come again? Why other formula?
oh, no, no, sir, no.
Okay, let me complete this. 4, 5 into point. Okay, you wanted to write in terms of area, you are telling me. But area is very, very smaller than the length, right? It's very negligible.
Yes, sir.
Uh, if you remove decimal point, here you will get 0, 5 5 ja, 5 1 ja, 5 1 ja, 5,000 ja.
1000.
So we are having 4 pi into the power of minus 7 into 5. Okay. Uh, 5 4 the 20,
Also
20,
into 1000, right?
and then
Into
1000.
1000.
Yeah. And over minus 7 is there, no? So 25 into the power of minus 4.
Um, so,
That equal to 2 pi into 2 pi 10 millitesla.
so we can leave the answer in terms of pi, or should we
If you want
substitute?
2 pi, pi equal to 3.142, right? How much it will become? Around 314 in the sense you can write 628,
Yes, yes,
6.38
yes.
something, right? So
Yes, yes,
therefore,
6.
answer is will come out be equal to 6.28 millitesla, right?
Yes, sir.
This is our answer. So this is the conclusion. Even I got, you people also will get radius. This is they are given in a centimeter, remember. Though you convert into meters also, 0.01 meters. In, in front of zero point 0.5 meters, 0.01 meter is very, very small. L is greater than R. Yeah. So R is neglected with respect to the length. Got it?
Yes, sir.
Next. Uh, yeah. Most important applications of biosolids is very beautiful applications we find here. The question is that it's also related with the atomic model for us. What's the question? In Bohr model of hydrogen atom, in Bohr hydrogen atomic model, an electron revolves around the nucleus. What did they say? An electron revolves around nucleus. Nucleus. Since it is revolving around nucleus in a circular orbit in orbit, orbit of radius of radius. How much they are given? 5.11 into 10 to the power of minus 11 meters at a frequency of 6.8 into 10 to the power of 15 hertz. 15 hertz. What is the magnetic field? What is the magnetic field? Magnetic field set up at the center of the orbit. Magnetic field set up at the center of orbit. Here you are having so many doubts, I understand. How this is related to magnetic fields? How the both are running on? You know one thing, there is a one concept. Whatever the magnetic field possesses because of the rotation of the electrons only, as I said before, it is a converse with that. It is a converse always. When current flows to the conductor, how it is magnetic field produces, where there are the magnetic field, current also produces. Same vice versa, it will be happening. So the question is that what is the magnetic field at the center of the orbit is the question, right? So what are all you are having here? Electrons revolving, then radius you are having. How much? 500 millimeters per second. And frequency has given. How it is related to the magnetic field? That is the most important thing you must know here. What is the magnetic field formula? In a circular wire or circular loop, use a loop. Any idea? At the center, like this diagram was there, we have studied. Let us say it is moving at the center, what is the magnetic field? Is a question. You did not get? Hello?
Yes, yes. So will it be
Hmm.
yeah, and then it will be 2 pi and the length of the radius.
Of course, 2 pi and all will come, but they will get cancelled. Magnetic field at the center of the circular loop or circular wire is this formula direct. At the center we found with respect to this. After circular law, with respect to this elemental length we found. In biot law, with respect to biot law we found. At the center, when we discuss loop followed by this different cases, we discuss this. Okay.
Yes,
So, of course, still there is a problem. How you can relate? Mu naught is a constant, radius, of course, it is there. Current. Current has not given in the question. So, but how we can find the current? Current in the sense the amount of electrons flowing to the conductor or wire, right? So, how can you write the amount of current flowing to the conductor or wire? I equal to number of electrons. Can I write per unit time? Is it right?
yes,
Now, in Bohr's hydrogen model, an electron revolves desert. Here also electron revolving in the orbit. While it is electron revolving around the orbit, around the nucleus in the orbit with the radius so and so, at a frequency of 6.8 into 10 to the power 15 Hz. Remember, how much frequency with that? 6.8 into 10 to the power 15 Hz. With that much frequency, it is moving. So therefore, electron charge, how much frequency means number of oscillations per unit time. right? Are you able to see here
Yes.
per unit time?
Yes, sir.
So I can take n for number of vibrations or number of cycles or number of charges. You can take anything here. So I took like this. So charge, how many charges? One charge they said, means one electron they said. So that's why n equal to 1 you take per unit time, you take 1.6 into 10 to the power minus 90. Now this is the total value of the current if you find. How much it is? 10 to the power 15 minus 90. Gives us question 10 to the power 15 only.
10 raised to
Mi-
minus 4.
minus 4. Minus 4, 6.8 into 1.6 into 10 to the power minus 4. So 68 into 16 we have to do. Okay. To do whatever I will do, will get current. Now what I am doing, this total value I am going to put here. Where in the
So it's
magnetic.
coming 10.88.
Okay, but if separately they'll ask current, then it is. Otherwise, you can 4 5 into 10 to the power minus 7 into I 6.8 into 1.6 into 10 to the power minus 4 by 2 into radius 5.11 into 10 to the power minus 11. Minus 7 minus 4 is 11, right?
Yes, sir.
Plus 11.
So if we write 10.88 like for the current value, then we can easily cancel it.
Okay. Uh, 2 into 5.11 is in denominator. Now what I am doing, 2 1 ja, 2 2 ja. So 2 5 I keep aside. 2 5 into 1, 6.8 into 1.6 by 5.11. Nothing is missed, no? Okay. Then
Mm,
what we are doing here? 5.11 into 6.8 into 1.6. Uh, how much if you calculate 68, no, 16, 16 8 ja, 16 4 ja 64, right? But 16 8 ja, 128. So 16 6 ja, 96, 96, 116, 108. Now here you are having 10.8 into 2 if you do 16, 1, means 21.6. 5 into 21.6 by 5.11. Now 5 4 ja,
20.
20 no? But
Yes, sir.
5.11 is there. 4 1 ja 4, 4 1 ja 4, 4 5 ja 20. 20.44. This is 21 now. 1.6. Again into 3.14. 5 value also you have to multiply, no? So
Yes.
21.6 into 5. How much you will get? What is the answer?
1 minute, sir.
21.6 into 3.14. 67.824 divided by 5.11. Then 13.27 we have an answer.
Yes.
13.27 Tesla the answer. This is approximately we have done. So this much we got. 13.2727 like this we got. We can write 13.28 like. So this is a way we will find in a case of biot law application. One more application if we see in the case of biot law. This is the most important one. A long straight wire carrying a current of 30 amperes. A long straight wire carrying a current of 30 amperes is placed in an external uniform magnetic field is placed in an external uniform magnetic field 4 into 10 to the power minus 4 Tesla parallel to the current wire. Parallel to the current wire means whatever the magnetic field is placed that is parallel to the current wire in the sense it is obviously like this. So magnetic field direction is like this. Now find the magnitude of resultant magnetic field at a point 2 centimeters away. At a point 2 centimeters away. Resultant magnetic field 2 centimeters away. Means R equal to 2 centimeters away from the wire. Now here how much current is flowing? 30 amperes. 2 centimeters is a radial distance is given. Means the point where we are measuring. Now how can we find the magnetic field? This is first question. Field due to a current carrying conductor or a wire is our formula. What is the formula we are having along the straight wire or finite wire? B equal to we can write up mu naught I by 2 pi r. Mu naught is a 4 pi into 10 to the power minus 7. I is a 30 amperes. 2 into pi value. Pi value is what? 3.14. Keep it pi as it is. Or radius is 2 centimeter. 2 centimeter if you convert into the meter, 2 into 10 to the power minus 2 meters. So 2 into 10 to the power minus 2. So pi get answer to 1 by 2 get answer. Now 10 to the power minus 2, 10 to the power minus 7, minus 5. So 31 means 3 into 10 to the power minus 4 means 0.3 into 10 to the power minus 3 Tesla is a magnetic field which we found. But this is along the horizontal direction I found. But they ask the question here, the resultant magnetic field. Find the resultant magnetic field in the sense, vectorially if you see along horizontal axis, along vertical axis, we have to go. So let us see how horizontal axis, vertical axis, we can obtain this. Find the magnitude of resultant magnetic field at a point. But they have given magnetic field 4 into 10 to the power minus 4 Tesla parallel to the current. Then one more option is also we should have, which is perpendicular. In the perpendicular direction, how much Whenever the field is acting perpendicular to us, how can we find that into the minus? Horizontal. So give it to B1 and B2. And the question is incomplete. We got the total, we got this. We don't know. Okay. In the question, the magnetic field which is perpendicular, this is parallel component has given. With respect to parallel, they have given. With respect to perpendicular, the magnetic field they have given in the question, that is 4 into 10 to the power of minus 4 Tesla. Please note it down. This is with respect to perpendicular direction. This is with respect to parallel we found already. But the questioner asked that what is the resultant magnetic field? Then some question has missed. That's why this problem. So result B2 equal to 4 into 10 to the power minus 4 Tesla in the sense resultant magnetic field. How can you find the resultant? Same like in vectors I said, right? Any two vectors are available. This is B2, sorry, this is B1, this is B2 in the sense resultant magnetic field in this direction it will act. That is sum of these two. Okay? Or it's a horizontal axis. So now when you wanted to find the resultant of this vector, what you have to do in a vector concept, B1 square plus B2 square we will do. Therefore, if you substitute these two formula, this is I am writing B1 as 3 into 10 to the power minus 4 I am writing whole square. B2 as I am writing as 4 into 10 to the power minus 4 I am writing. This is also whole square. To achieve the resultant value, 3 into 10 to the power minus 4, 10 to the power minus 4. If I take the common, since root is there, 10 to the power minus 4, from the both cases it comes out. But rest of the 3 3s are 9, plus 4 4 is 16. It gives us 25. Then 5 into 10 to the power minus 4 is a resultant magnetic field. 5 into 10 to the power minus 4 Tesla is a resultant magnetic field. In the question, actually, the questioner has not conveyed the perpendicular one, whether in the question or not, but they missed to give that. But perpendicular value is this. Okay.
Yes, sir.
Next. This is an interesting one. A wire placed along the north-south direction. Along the north-south direction. Carries a current. Carries a current of 8 amperes. of 8 amperes from south to north. From south to north. Find the magnetic field. Find the magnetic field. Magnetic field due to a 1 centimeter. Due to a 1 centimeter piece of a wire. Piece of a wire. Piece of a wire with a point. At a point 200 centimeters. 200 centimeter. Northeast from the piece. 200 centimeters northeast from the piece. From the piece. The wire plays along the north-south direction. First, in this question, what we have to do in the sense, we always prefer to take like this. Directions is not. We have to follow the normal direction we have to take. Prefer, then we will do that. In which direction north, which direction south if you are taking, then this is north, this is south. Okay, then east, so west. This is west, this is east. So when you take like this, with respect to this, your question you have to solve. What is the question? A wire placed along a north-south direction. So we place a wire like this, north-south direction. Carries a current of 8 amperes, of course 8 amperes. From south to north. South to north. Now, find the magnetic field due to a 1 centimeter piece of a wire. Due to a 1 centimeter piece of a wire at a point 200 centimeters northeast. Northeast means this is the north, this is the east. In this direction, at a distance of 200, we need to find out magnetic field. Magnetic field, right? And with
Yes.
respect to what? With respect to 1 centimeter piece, magnetic field due to a 1 centimeter. This is a DL we will take now. This is 1 centimeter north. Now question, you understood? What is the question?
Yes, sir.
Means here we have to apply 1 centimeter length. With respect to this, how much magnetic field it is possessing or producing, we need to find. So we have this set of questions for this suitable formula. We know that what is that? What is this formula?
Biot Savage laws formula.
Exactly, bias formula.
It will
Mu
be
naught by
D is
4
equal to mu naught by 4 pi into dl into r by r cube.
ideal sine theta. We are not writing in vector form, right? Ideal
Yes.
sine theta by r squared since it is inverse square. So dt small amount only will produce mu naught by 4 pi 10 to the power minus 7. Since 4 pi has come down now, so 10 to the power minus 7 into that. I, I 8 amperes. DL is for 1 centimeter, they said. 1 centimeter we will express into the meters. So I am writing 1 into 10 to the power minus 2 and sine theta. Sine theta in the sense the angle in the, of course, the angle they did not mention, but they said northeast in the sense, obviously mid east. It is 45 degrees,
Yes, 45.
right? Middle of 90 degrees. So sine 45, how much it is? 1 by root 2.
1 by root 2.
So since it is 1 by root r square is a 200 centimeter. 200 when you convert into 100 is a 2 meters, right? 2 2 ja
Yes.
4. Directly I square. 4 1 ja 4 2 ja. Now we are having 2 here, root 2 here. So 2 can be written as root 2 into root 2. Then here I have root 2. This root 2 cancel. I have here
Yes.
root 2 into, I have
10
here
raised
root
minus
2
9.
into 10 to the minus 7 and 10 to the minus 2, 10 to the minus 9. Right? Root 2 value
Yes.
3, 1.414
1.414.
into 10 to the minus 9 uh, Teslas. Can I
Yes.
write?
Sir. Yes. Sir.
Yeah, this is my answer. dB value.
So the vector formulas won't be used much in numericals, right?
Exactly, exactly. The vector concepts are important always.
Only concept, but like there's not any application, right?
No, no, no. It's a trigonometry ratios and a resolution concept. It will be applicable. For example, just now we were discussing previous problem resultant. Resultant in the
Yes.
sense, this is a arrow mark you are seeing. This is neither x-axis nor y-axis. This is the resultant position. Along x-axis how much? Along y-axis how much? You have to square it. Dx square plus dy square. This gives a resultant one. Okay.
Yes.
Direction theta equal to tan inverse dy by dx. Means whenever you consider this is as a vector, that time it will be.
Yes. Okay.
Okay. Otherwise, the questioner will ask the question, what is that? What is this? Like directly. Then that time it is. Okay.
Yes.
Now, few more numericals we will discuss, and we will enter into the new lesson with this also. So, here in this case, biot law and anthroposophical law numericals will be asked more, and not only those conversion